Okay, after some technical issues, we allowed to people who are joining late to be on track with us. So welcome to our webinar about unlocking the power of Asset Framework. My name is Piotr Wedziuk and I am PI System expert at ConnectPoint. As a PI System integrator, we help our customers to get most of it. Although Asset Framework has been out since 2007, in many cases its full potential is still not utilized or not used at all. We would like to show you how we approach it and share some tips. It is the first one in a series of webinars, so for example, asset analytics will be covered in the later ones. I hope you will find it informative, and let's start. So here's our agenda for today. At the end, we'll host a Q&A session. So if you have any questions, please write them down in a chat, and we'll answer them at the end. Quick info about ConnectPoint. So we are a PI System integrator. We specialize in the following industries such as power, manufacturing, utilities, and many more. We are based in Poland and also in Germany and have partnerships with Aviva and other software companies that you can see on this slide. What we do is basically we do everything around PI System, including data processing, implementation, maintenance, integration of PI System. We develop seamless IoT and IT integration systems, optimize algorithm calculations, and also provide trainings. Our team basically has all the certifications acquired from OSIsoft. That's some of our clients. As you can see, we have a wide portfolio of customers from different branches and industries. Let's start with a quick introduction to Asset Framework itself. So in the world of data management, think of data model, which is our first point, as the heart of the PI System. It's that important, actually. It's not just an extra thing, it's a key application on its own. Speaking about context, the data model takes raw production data and gives you a story. It adds context, making the information more meaningful. As you explore PI System, you realize that data model is affecting how we name things like PI tags. This careful naming isn't just for looks, it sets the stage for easy integration. What you create in Asset Framework shapes what the user will see in the PI Vision and other tools. But the data model goes beyond appearances and the hierarchy. Instead, it's like starting point opening doors to deeper understanding and interaction with the data. Also, last but not least, the exciting part about the data model is that it's not limited to production data. It's flexible, embracing information from various sources. This means we can get insights not just from the factory floor, but from different connected sources too. Let's then embark on a journey through the rich landscape of Asset Framework features, each contributing its unique essence to the PI System. At the foundation of Asset Framework lies the concept of elements and hierarchy. It's like organizing your digital universe. Elements create a structured hierarchy, helping you make sense of your assets and their relationships. Enter the library next, a place of predefined templates and configurations. It's your toolkit for consistency. The library ensures that your assets follow best practices, save your time and effort. It's like having a set of blueprints ready to go, making system setup a breeze. Then, moving to Asset Analytics, which is the smart thinking behind the strong muscles. It helps us deriving meaningful insights. With Asset Analytics, you can set up calculations and analysis, turning raw data into actionable intelligence. It's the savvy data interpreter helping you make informed decisions. On top of it, we have PI notifications that take communication to the next level. It enables people to take timely actions. This feature lets you set up notifications, ensuring you are alerted when the things need attention. And here's the underrated hero, REST endpoints. They're an out-of-the-box solution allowing integration with other systems, making communication smarter and more versatile. Precision matters, and units of measure bring that precision to your data. It's like speaking a universal language. This feature ensures consistency in how measurements are expressed, avoiding confusion and errors. Last, but certainly not least, we have categories. They are organizers of your information. With categories, you know what kind of data you have at hand. Categories help you classify and group assets, making navigation and understanding your data. Let's dive deeper into the distinct designs and functionalities of asset framework databases. So, an intuitive choice for the IF model might seem to be a technological one, but it might not be optimal considering the business needs of particular organization or department. When it comes to IF database, data organization can be tailored for direct reporting from asset framework or organized with a focus on integration with the data warehouse or a report stage. Let's look at the specific designs one by one. The technological one focuses on optimizing technical processes, ensuring that operation efficiency is at the forefront. An analytical one, on the other hand, serves as the brain behind the system, emphasizing in-depth analysis. The reporting design is geared toward generating insightful reports, providing valuable data-driven reports. Finally, the visualization one is all about transforming your raw data into visually comprehensive narratives, simplifying complex information for better understanding. Last but not least, we usually have a development or test database, which is used to test and verify your new elements or calculations before they are implemented into a production database. A good practice is to keep your number of databases to a minimum. If people use PyAsset framework by building their own databases, they have just moved many of the problems of the spreadsheet into the server world. Ideally, PyAsset framework databases should be public and set up so they can be reused, adapted, and be allowed to evolve. This is an example of a reporting IF database, which we built to serve this specific purpose for PGE, which is the largest energy sector company in Poland. Data is being entered manually through forms read by interfaces, obtained directly from the process structure, and calculated through analysis and formulas. Data is entered at different intervals depending on its nature. Monthly or daily reports are generated covering data in the following areas: environmental protection, fuel supply, and consumption, indicators determining the efficiency and availability of generation unit, and many more. The structure also collects data on failure rates and emergencies like fires, hurricanes, and so on. In the mining part, we monitored parameters related to mining and conditions of equipment like excavators and dumpers. Production data, equipment states, and KPIs are monitored and reported at the level of individual machines and the entire mine. The structure is continuously modified and expanded in line with the changing legal conditions and customer demand. When it comes to visualization model, we want it to be organized the same way as our displays, or as closely as possible, of course. More often than anywhere else, we would like to see the, for example, current shift data on our visualization screen, and this metric will be included under an IF element, regardless whether it's a raw or calculated value. Here on this slide, we can see a visual representation of a technological model. Data is attached to each of the specific devices, and this is something that probably operators who can do screens are used to work with. Of course, nothing prevents creating visualization out of this model if we have models of that equipment, like in this slide, we have like 3D models of the specific equipment. People working on the factory floor would certainly appreciate a one-to-one visualization model of what they usually see in their work. Moving forward, let's explore principles guiding the structuring, naming conventions of objects within the IF library. Adopting a standard helps navigation, interoperability, exchange of data between applications, and ease of use across the site for users. For example, for batch manufacturing, we have ANSI ISA standard and RDSPP, which stands for Reference Designation System for Power Plants. They're already there for us, so we can only benefit from using them. We don't need to reinvent the wheel from scratch. If the structures of PyAsset framework hierarchies are laid out according to an industry or internal standard, then it's easier to automatically configure the elements and attributes associated with the structure. Following a hierarchy structure standard is advantageous if you already have the PySystem deployed across multiple sites, especially if those sites acquired PySystem individually or were acquired from other organizations. In situations like this, you can use PyAsset framework to present the data to the user in a consistent fashion. On the left, you can see the part of the batch manufacturing standard, how it divides the equipment, depending on its level. Let's talk about the templates in the AF system. Templates stand as a cornerstone in the PySystem, strongly recommended by its vendor for a good reason. They serve as blueprints offering a structured approach to defining various PyObjects, including elements, attributes, analysis, notifications, and so on. Templates streamline the configuration process, ensuring consistency and efficiency in the creation of assets. They act as a guiding force, promoting best practices and facilitating standardized data management. Templates empower the utilization of advanced features like asset context switching in PyVision, for example. This capability allows users to dynamically switch between different assets within a single display, providing a contextual lens into various dimensions of data. Asset context switching enhances the user experience in PyVision, providing a dynamic and comprehensive view of data. Then templates also bring added value when it comes to integrations with third-party tools. They offer an additional layer of dimension to data, whether it's a site-wide or region-wide. This structured approach ensures that data is not only organized within the PySystem, but also harmonized for seamless integration with external tools. This becomes particularly advantageous when extending the reach of your data beyond the PySystem, providing cohesive and standardized data for diverse applications. Thinking ahead, we need to mention Aviva Data Hub, which elevates the capabilities of the PySystem to a new level. This cloud-native software as a service ensures secure real-time data access even for the users beyond company network. Its native integration with Aviva PySystem enables a smooth transition of operations data to the cloud at the company's pace. Such integration can only go effortless with the properly designed asset framework. Let's see how working with templates works. In the world of asset framework, templates serve as a base schema, providing a wealth of capabilities. They are not just a tool for managing singular assets, but unlock powerful features like PyTag building feature or interactions with OSIsoft products like PySQL client and PyIntegrators. The advantage of templates become evident when considering future comparisons between similar equipment or processes and when structuring assets within a larger context. One noteworthy application of templates lies in the concept of derived templates. By pushing common attributes to the higher level templates, organization can streamline implementation efforts and open the door to cross-asset reporting. This approach not only enhances efficiency, but also ensures a consistent reporting structure across assets. Another strategic practice involves employing so-called supporting child attributes to store, for example, configuration items and parameters of the parent attributes. This approach ensures that the actual data attributes remain at the top level. One of the examples of this child attributes usage is, for example, considering a child attribute with different units of measure than its parent. This hierarchy allows for effective conversion of units of measure without compromising the structure. Then we have substitution parameters that add another layer of depth to attribute naming conventions. While default parameters that we all know, such as element, attribute, and ID, are beneficial, exploring deeper parameters such as zone, country, site, and so on offer a richer and more context-specific data representation. Next, we have metadata attributes that serve as markers in client applications, especially in PyVision. While working with element relative displays in PyVision, again, adding hierarchy context to a display can be challenging. Here, metadata attributes play a crucial role, acting as markers that reveal the hierarchy, facilitating a deeper understanding of the displayed data. However, even if you name elements carefully, you will find it difficult to see the hierarchy in a PyVision display when you are not in the build mode. For example, if you are looking at the display of wind turbine, you might not easily know where the turbine is actually located. You would need such kind of marker attributes such as site or region that show the location for each turbine, so you can add them to the display and have them update when you flip between the turbines. This is also relevant when using, for example, PyIntegrator for business analytics. When you move the schema of the template into a record-oriented database through the integrator, it does not reflect your hierarchy that you built in Asset Framework unless you provide for this. One of the tips we follow is to always use templates even if you have only one of something. You will benefit when you compare with other plans or when you add a site that has the same or very similar equipment structure. Remember that PySystem has the convert to template feature that you can always use when you complete building your element, and then just to simply convert it to a template ready to be reused. Also, do not create many elements if you don't have to. You can design large elements with many attributes and use categories and child attributes to organize them. Also, we should not forget about other types of IF library objects, such as IF tables and enumeration sets. The first one, so IF tables, are dynamic repositories that extend IF capabilities by incorporating data from external sources. For instance, it empowers users to pull in relevant information from external databases or systems. Another example is a situation where a site lacks a predefined pattern. IF table can be utilized for creating a custom naming convention. Despite these examples are the most common ones, we also have the table provided time series data rule when we configure a table lookup attribute, and we can pull the data directly to Asset Framework, kind of by avoiding the Py data archive. It can save us some Py points if we are close to the license limit. Then enumeration sets serve as a valuable tool, particularly in scenarios involving manual data entry. By providing users with a predefined set of values to choose from, we not only know our data, but also can prevent human errors. They contribute to data consistency and accuracy. Moreover, enumeration sets can be quasi-dynamic through scripting, a customization that we successfully implemented for some of our customers. Categories, which are often underrated, emerge as a versatile tool with the PySystem framework. PyAsset framework, of course. They act as labels, allowing attributes to be recognized by usage, be it from reports, visualization, or integrations. This categorization doesn't modify the hierarchy itself, but offers a powerful tool to organize the data effectively. When used to distinguish data types, categories separate real-time from static or calculated from raw values. Another use case is organizing attributes when the categories assist in grouping attributes into subsystems and isolating configuration values that we already mentioned. Looking at PyClient, categories is building attributes queries in PyVision and PySQL products. They can also serve as input to rollup analysis and custom data references. We highly utilize categories in our SmartRDM application, which integrates PySystem through PyWeb API. Using certain categories, we tell our application which and how certain elements should be reflected in it. As you can see in the picture, the cutting machine 1 that is highlighted in yellow has category _3, which for SmartRDM means it should be displayed in the tree of the forms. On the other hand, event frame config category means that the event frame referencing this element would show up in the module when we can edit event frames by, for example, trimming them or splitting. The use of categories does not really affect the production AF data, and we don't need to rebuild it for that. While on the other hand, it gives the admin full freedom to configure the assets like they need to. Categories, unlike the other AF objects, are flat and allow to implement a new dimension of object grouping. Categorizing an element doesn't propagate that category to its parent or children. Let's jump into tags and AF naming convention part. One may ask, why should we should carefully name our PyTags? Assuring that PyTags are carefully named is crucial for effective data management, and here is why it matters. A shared understanding begins with a common language, especially in the global companies with sites in different countries. Careful naming establishes a common grammar for the entire dataset. Among vast volumes of data, precise naming ensures easy retrieval. While a clever name might be tempting, simple one is usually the best. A thoughtful name assures swift access without getting lost in the sea of information. Precise naming greatly facilitates data treatment processes. From sorting and comparison to in-depth analysis, a clear and consistent naming structure streamlines these essential data handling activities. Also, carefully named PyTags contribute to the organization of worldwide global repository of raw data. A standardized naming convention ensures consistency, making it easier to navigate through the extensive database of our data. Then, the name of our PyTag also can provide insight into the nature of the data it represents. Whether it's an alarm, event, area data, or specific product name, a well-crafted name serves an instant descriptor. Accurate names are a guarantee of data quality, which is very important for everyone. Avoiding name confusion and implementing coherence checks ensure that the data associated with each tag is reliable and error-free. When you employ a naming standard, you improve interoperability, exchange of data application, and make it easy to retrieve and work with data across sites. If you name your PyTags according to internal or industry standard, naming the elements and attributes accordingly make it easier for you to configure those elements and attributes automatically. Even if the PyTags are named differently across sites, you can present data to users in a consistent fashion across all sites by following a standard. This will allow users to focus on how to use data rather than how to find it, and frees them from the distraction of memorizing PyTag names. Here we present an example of informative PyTag name. In the prefix, we have asset location data in the grand scheme, so zone, country, and plant, for example. Its body is responsible for a lower level description, which tells the user where exactly in the plant or within the area or machine the data is, let's say. And then the suffix tells us actually what kind of measurement or calculation it is. Okay, and what we get from all that work and effort and time primarily spent on our naming convention. First, when we employ best practices in naming, they streamline product implementation, reducing unnecessary times during setup. Also, well-named raw data is universally understood by the entire business team, improving collaboration within and between various plants. Careful naming significantly aids in building the initial structured data model like the AF equipment tree, resulting in easier maintenance and future development. Also, standardized naming convention provides a ready framework for introducing new sites and equipment. That's why when we design, for example, our internal standard, we should take into account potential expansion in the future. Also, well-named flat data model serves as a robust foundation for manufacturing data lake, enhancing data storage and retrieval efficiency. Precise naming ensures that obvious correlation between flat and structured data models, maintaining clarity in interpretation. And lastly, thoughtful name breaks down compartment that we use of our data, for example, for ARIA, promoting a holistic view for better decision making. So also good names, when we employ them, enable you to use names directly as lines in a report and avoid the need to retype them. They also make it easier to find objects in searches and identify them using the common language. We believe that it's better to have the great names and no description than cryptic name and great descriptions. On this slide, we present you an example of our customers' AF tree from the ceramics industry. Navigating from the top, we start with the name of the company, then we have one of the sites, and next we drill down to a processing area. Taking a closer look at the spray dryer, number 1, we see a few child elements which we created to differentiate data sources for the dryer, such as an energy meter and I/O link. Besides, we have the 3 elements starting with export name, export word, which hold data, even frame generation analysis, and PI notifications that we use to export data to external ERP model system through PI notifications targeting REST endpoint. The actual spray dryer element has only the attributes we need at its level, where the other calculations can be done underneath. Here we can see also some recommendations being implemented, such as using mixed case names rather than, for example, all capitals, and spaces used instead of underscores or dashes. So in our daily job, we assist our customers in designing or developing their PI systems, and we believe that during that process, collaboration is a key. Because we need to consider their vision of equipment as a collaborative effort to organize assets effectively and size the opportunity to enhance their existing data model. We also need to acknowledge that designing the PI system involves a trade-off between existing structures and practices and an optimal setup that we believe it will be optimal in that specific case. Balancing these considerations ensures a practical and efficient system for both sides. Many companies switch from vendor-provided HMIs to PI Vision, for example, often with expectation just to simply recreate them in PI Vision. However, this transition is an opportunity not just to recreate them, but enhance these interfaces, aligning that data and those visualization with all the PI Vision capabilities. Also, a good practice from our side is to work with subject matter experts if you are not one of them. They know the process, unit, and piece of equipment, and what is important about it. And let's jump to some golden rules about naming our PI tags. Starting with the number 1, we have the hard-coded rules that names must begin with alphanumeric character, underscore, or %. We also have some inclusions that we need to take into account, such as we cannot have control characters like line, fills, or tabs, or question mark and asterisks, which are reserved. Then what we should avoid is to use special characters, for example, like special for the specific language. And although some of them might work, we advise against them because they can be troublesome sometimes. And last but not least, we should think about the scale and anticipate the growth of your model. Ensure that naming conventions don't become constraints when you grow and your model expands. And flexibility is a paramount for accommodating evolving requirements. One tip from our side as well, actually one of our customers has assets spread all over the world, and they also have various manufacturers and models. To unify their PyTags, they implemented such naming standard that you can see, and it clearly identifies the location of an asset and its parameters. Data from various sources, we have data from various sources and from various vendors. So sometimes they differ between the tags itself, and the PyTags are configured differently. But what we see in the PyTag itself, it's the same. It's transparent, and we know that this setter metric identifies the specific parameter, although the source of it is different. Let's see how we approach the asset framework data models. We should think about the composition of a standard in IF3, and this is why. First of all, the IF3 and naming conventions are bound together. Each defines and influences the other. The symbiotic relationship ensures a well-organized structure throughout the IF3. Also, a standardized decomposition in the IF3 makes the system relatively easy to understand, even for someone who is interacting it for the first time. It also simplified the model, onboarding model for new people, and simply it's user-friendly. The implementation of a standard decomposition introduces also clear logic into IF3. Also, when we take care of a good model, it simplifies maintenance and future development. So we can easily introduce new assets and plans and so on. We believe, and I believe it's true that the best model does not really exist. It really depends on the purpose. So IF databases can be different simply, and depending what they're served for. For example, as we already mentioned, we have analytical model, a reporting one, visualization was specified for a specific third party like data warehouses and so on. And in the essence of it is that flexibility in representing data and the ability to distinguish databases designs ensure that IF databases are not one size fits all. Also, how we look at IF is that it's not only a start; it's only a start point for the future and for the further development. So, design choices made to your asset framework extend their influence on the selection and utilization of other tools. From visualization to reporting and seamless integration with other systems, IF design sets the stage for optimized usage. Then we have external integration, which, for example, as simple as Py notifications sent to the REST server, as I already mentioned, requires careful consideration. Metadata included in event frame properties, for example, is crucial for its primary elements that those event frames reference. Adding this metadata later may cause backfilling need, posing risk to data integrity. Additionally, all the notifications are not resent when we backfill them. So it's emphasized the importance of getting this configuration right from the very beginning. We also need to think about development of custom applications through tools like PyApp API, AF SDK, and PySQL products family that rely on the well-designed data model. The design choices made in the AF influence how developers actually code that applications. And even going beyond PySystem, we should also think that AF structure simply drive and support usage of asset analytics. Okay, let's have a look at two quite common mistakes in asset framework design. Sorry, okay. Okay, sorry, just had to check something. Yeah, two common mistakes in asset framework design that we saw in our real life scenarios. So sometimes it might seem convenient to use generic templates for similar assets from different vendors even, but it can lead to issues such as attributes without reference PyPoints or vice versa, so unlinked PyPoints in asset framework. It should be avoided to maintain a well-structured and functional asset framework which does not have any PyPoint not found on other type of errors. Also, consider the nature of your data when configuring attributes. In cases of more complex analysis that take time, computation can actually exceed the trigger interval, which makes the calculation actually run longer than it's configured to be triggered. Also, sometimes some effects of that kind of mistakes might appear harmless, but with the large asset framework structure, then can lead to issues with asset analytics not performing very well. After looking at the front of the asset framework, let's look what is under its hood and how to keep it running in a healthy state. First of all, we should correctly size our SQL server and AF server, of course. We should make sure that they are appropriately scaled to our data volume and number of operations that we perform on it. In the past, OSIsoft, and now Aviva, of course, offers a sizing tool which we also recommend to use. And also, when using it, don't forget about that your system will likely grow. If needed, consider implementing a highly available setup for AF, SQL Server, or both. However, the SQL Server 1 is only available in the Enterprise Edition, so don't forget about this. Also, PyAnalysis service can be placed on a different node than AF service, so if you run heavy calculations, consider this placement and isolation as well. Also, with Asset Framework database comes OSIsoft AF maintenance SQL job. So it's a good practice to run it frequently, which mitigates risk of performance degradation and enhance the overall stability of the system. Also, we should not forget about monitoring of AF, analysis, and SQL services, which allows us to proactively identify and resolve issues, preventing potential disruptions to the system itself. And beyond those services, we should monitor overall performance of our PySystem infrastructure. So also the simple IT monitoring to avoid issues and potential bottlenecks. Okay, let's sum up the presentation in a few points. So in the dynamic realm of asset framework development, it's crucial to adopt an approach that takes into account continuous future considerations. Asset models mostly grows continuously, and that should be taken into account. Also, to effectively administer the system, we recommend usually to internally organize a team of experts that are dedicated to that task. And also, even with the internal expertise in the processes, like many of the companies have in the industry and equipment, it's always good to seek an advice from experienced professionals versed in various branches, scales, and work cultures. Also, it's worth investing extra time in initial design and planning, because that can save us time in the later time when we need to deal with the poorly designed AF. Last but not least, of course, we should think about restricting production database to only trained individuals and trusted editors. And that also is linked to the fact that we should have a test or database library of our database. Okay, that's all from our side for the presentation. Now let's